Hi guys, we're going to look at the first example. So what we have here is this is an inside problem where they intersect inside of the circle. I'm going to take the two that are on each line and multiply them, which is what my formula for this one says. So in this case, I end up getting 10x equals 210, divide by 10, divide by 10. You get x equals 21, and that's my answer. So I'm going to match up. This is still an inside problem. They're intersecting inside of the circle. I'm matching up the 2 here, the 2 here, and I'm just going to start, okay? So I have to multiply them. So I have 6 times 6. I have 4 times 5x minus 1. I get 36 is equal to 20x minus 4. Do a little bit of math gymnastics. I get x equals 2. This one's the length of BD though, so let's plug that back in. Well, that's 4 and this one combined. So I'm going to have BD equals 5x minus 1 plus 4. And let me substitute in my x that I just found. I have 5 times 2 minus 1 plus 4, which is 10 minus 1 plus 4, which gives me BD equal to 13. And that I'm just going to put right down here. Number 3, still a problem that has to do with the inside of the circle. These are chords that are intersecting inside the circle. So I set up, okay, those are the two that match. I'm going to start multiplying them. 27 times x plus 5 equals 24 times x plus 7. Here I'm going to end up distributing. I get 27x plus 135 equals 24x plus 168. Do a little math there. I get x equals 11. And that's my answer. Okay, so looking at number 4, this is still one that intersects inside of the circle. So I'm just going to match up the ones that break up each chord. Okay, and I'm just going to use the formula that tells us where I can just multiply them. So I have 18 times 2x minus 5 equals 14 times 2x plus 1. Okay, I'm distributing through. I get 36x minus 90 equals 28x plus 14. Solve that out. I get x equals 13. Not done yet. They actually want TQ, so let's keep going. TQ, because T is in the middle here, TQ is just this 2x plus 1, so it's 2x plus 1, which is 2 times 13, because that's the x that we just found, plus 1, which is equal to 27. So TQ is equal to 27. Put that here. Okay, we're going to start looking at number 5. This is the first example of ones that intersect outside of the circle, so we have 2 secants here. I'm going to just double bold the one that's kind of outside and just circle the one that corresponds with it but is inside. The other thing that I'm going to do is the same thing, different color over here. And then I'm just going to multiply. I bold these ones because I know those are the ones that goes before the parentheses. Those are my A and my C if you're looking at the equation. So here I get 8 times 8 plus 19 equals 9 times 9 plus x. I can add those two. Here I'm going to get 8, and then here's 27 equals 81 plus 9x. Make sure you distribute it into both. Here, I'm gonna get 216 equals 81 plus 9x. I solve that, I get x equals 15. That's my answer here. So I get x equals 15. Okay, do the same here. Double bold the ones that are outside. This is definitely one that's intersecting outside of the circle. I'm just gonna circle the one that it matches up with. We have that, and we have this. And let's start with the equation. So here I'm gonna have 10 times 10 plus 42 equals 13 times 13 plus x. Okay, I get 10 times 52 equals 169 plus 13x. Okay, solve that down. You get x equals 27, and that's my answer. This is still one of the outside problems, so I'm gonna double bold this, circle, bolt that up, circle, and let's just go through. So I have 8 times 8 plus 3x plus 4 equals 7 times 7 plus 5x plus 2. Inside, I'm gonna add my 8 and my 4. So I get 3x plus 12 equals, inside here, I'm adding my 7 and my 2. So I get 7 times 5x plus 9. I'm gonna distribute on both sides. I have 24x plus 96 equals 35x plus 63. Solve it out, you get x equals 3. Same thing, two secants intersecting outside of the circle. Double bold, circle, double bold, circle. So here I'm gonna get 12 times 12 plus x plus 8 equals 15 times 15 plus x minus 1. Combine the same things that we did inside on the last one. So here I get 12x plus 20 equals 15 times x plus 14. We're going to distribute into both. I get 12x plus 240 equals 15x plus 210. Solve that, you get x equals 10. But I do need to plug back in because they want yz here. Yz is this part here, that's x minus 1. So I have yz equals x minus 1. Yz equals 10 because I'm substituting in the x. 10 minus 1, so yz is equal to 9. And that's gonna go there. Okay guys, this is the next set of problems where it's the third type. So this is when you have a tangent intersecting a secant outside of the circle. As you can see, there's not another number over here. We're still just circling this because this is gonna be the one that ends up being squared. This is my A in this case, okay? So here, we're just gonna go with what the formula tells us. So it's gonna be this squared. So I get 24 squared equals, now here's the thing, I want you to put this in parentheses. It might not really affect this problem or much, but when we get to further problems, it's really going to matter. So for just the habit of it, make sure you're putting that in parentheses. Same thing over here as it was kind of in the last problem. It's 18 times 18 plus x. So here, when I square this, I get 576 equals 324 plus 18x. Solve that down, you get x equals 14. Okay, this is the same type of thing. It's going to be a tangent intersecting the secant outside of the circle. Make sure you're still just bolding this. Bold this. Circle that once. This one's going to be squared yet again. Good habit, put it in parentheses. Equals, here's going to be 8 times 8 plus 5x minus 1. 16 squared. Honestly, we should know that one in our head. This is going to be 256. Okay, we get in here, I'm going to combine the two of those. It's going to be 8 times 5x plus 7. I'm going to distribute the 8 through. I get 256 equals 40x plus 56, and I'm going to solve that down. I get x equals 5. We're not actually done yet. They want Pn here. So I look, what is Pn? It's just this segment right here that's labeled as 5x minus 1. So I have Pn equals 5x minus 1. Pn, if I substitute that 5 in for x, it's 5 times 5 minus 1. So my answer, Pn, ends up being 24. Circle that. Put it down at the bottom. Okay, looking at this, okay, what is it? Oh, this is still the type that has a tangent intersecting a secant outside. So I'm going to double circle this, double circle this. Okay, so same thing. I'm just going to set up. This one's going to be the one that's squared. For right now, let's put it in parentheses. I also get 27 plus 21. X squared is just x squared. Here, let's add these ones before we actually try distributing the 27. So I get 27 times 48. I get x squared equals 1296. Okay, so we want to get rid of the squared. Obviously, we know we should be square rooting. If we remember from the previous lessons, it should be plus and minus whenever we square root. However, that leaves us with x equals positive or negative. The square root of 1,296 ends up giving us 36. The issue here is when I break this up, I get x equals positive 36 because the plus, and x equals negative 36 because of the minus. We can have a negative x, but let's see if we can have it in this case. So that's going to be x. I can't have a negative 36 length, so I'm going to cross that one out. This is my only answer. So put that down at the bottom as your answer. Okay, here we go. Let's set this up. This is a tangent intersecting the secant outside of the circle. This is going to be the one that I have to square because it's the tangent. Okay, so before I said make sure you're putting in parentheses, this is the one that usually matters. So I have 3x squared equals, and now I have 9 times 9 plus 16. Here's why. A lot of you will end up not squaring the 3. Here I can put the squared with both of them because there's no addition or subtraction between the two of them. So it's 3 squared, which gives us 9, and x squared, which is just x squared, equals, we have 9 times, we're going to add the two of these together and get 25. At that point, this one ends up being a little bit weird. You get 9x squared equals 225. Which one do you do first? Get rid of the 9 or get rid of the squared? You got to get rid of the 9 first. So let's divide it by 9. Divided by 9, you get x squared equals 25. You're not done. You still have to square root. So here, I'm gonna square root, but when I square root, it should be plus or minus. Okay? I get x equals plus or minus the square root of 25 is 5. Let's break that up, see if we can work this. We have x equals 5, we have x equals negative 5. 3x, that's not gonna help me because this is gonna give me a negative side length, so that one's not gonna work. However, the x equals 5 will. So that's my answer. Okay, so we're kind of back to the set. It's going to be a little bit of a section of you decide which formulas you should use. So this is one where there are chords intersecting inside of the circle. So I'm going to use probably the most basic one where this multiplies with this multiplies with this. Okay, so I have 12 times 10 equals x minus 1 times x plus 6. Over here I get 120 equals, do not forget you have to FOIL or double distribute. So I get x squared plus 6x minus x minus 6, okay? I'm gonna combine the like terms here. I get 120 equals x squared plus 5x minus 6. Here's the thing. I have a x squared term, an x term, a constant, and another constant that isn't going to cross out either of these three. So I know here I'm probably going to have to FOIL or factor. So let me move that 120 to the other side. I get 0 equals x squared plus 5x minus 126. Okay, so we're gonna have to factor that. So I end up using my T-chart. If you don't want to use your T-chart, that's fine. I need two numbers that multiply. This is a 1 in front, so it's multiplying by negative 126, and it's gonna add to a positive 5. So take your calculator, put 126 in, start dividing it by 2, 3, 4, 5, see what pairs you get here. The numbers are gonna be generally pretty close for it to have a difference of 5 here. So looking at this, I just keep trying numbers. In this case, I end up getting the numbers 9 and 14. They have to multiply to a negative, so one of these two have to be negative. So let me see if it's going to be negative 9 and positive 14 or positive 9 and negative 14. It has to add to a positive 5. So it's going to have to be this one because the 14, the bigger number, needs that positive sign. So I go back here and I break this up. So I have 0 equals, it's going to be x minus 9, x plus 14. Set each of them equal to 0. I get x minus 9 equals 0, x equals 9, x plus 14 equals 0, x equals negative 14. Let me see if the negative would work in our problem. Nope, wouldn't actually work in either, so that's not gonna work. However, over here I have a 9. That does work when you plug it in the problem. So I get x equals 9. Not the solution, okay? Okay, so this is what we got. This is gonna be, let's see, it's not a tangent, so it's two secants intersecting outside of the circle. So this is the one where I double bold, single bold, double bold, single bold, definitely technically more than double, but we're going with it. So these are gonna be the ones on the outside. 4 times 4 plus 2 equals x times x plus 5. Okay, so we're just gonna go through and solve it real quick. So on this side, I get, this is 4 times 6 equals, I can't really do anything but distribute the x here. So I'm gonna get x squared plus 5x. This side is going to give me 24 equals x squared plus 5x. I have an x squared, I have an x, and I have a constant. They're not going to cancel out in this case, so I'm going to have to factor. So let me move the 24 over. I'm going to subtract 24 from both sides. So here I get 0 equals x squared plus 5x minus 24. Make sure you're careful with the sign. That's sometimes one of the big issues that we get with this is you want to move it over and you have a positive sign. Even if it's leaving it with just x, make sure you're showing your steps here. I am going to make my t-chart. Makes everything easier for me. We need to see numbers that multiply and add. So that's a 1 in front, so I'm good. It multiplies to negative 24, and it has to add to positive 5. So looking at this, let's look at numbers. Divide 24 in your head, honestly. So 124, you have 8 and 3. Yep, that looks like that one's gonna work. 8 and 3, it's a negative, so it has to be one of these has negative with it. So let's look at our options. Okay, so which one do we pick? This is a positive 5, is it sum? Well, that bottom one works for us. So I'm gonna pick that, and I'm gonna go back to the right there and break this up. I get 0 equals, and this is gonna break up into x plus 8, x minus 3. Set each of them equal to 0. You get x plus 8 equals 0. Minus 8, you get x equals negative 8. Here I get x minus 3 equals 0. At 3, I get x equals positive 3. Let's check to see if these ones work. In this case, the negative 8 doesn't work there. That's going to give me a negative blank. However, the 3 will. Okay, so let's just plug our answer in down here. Move on to the next one. Number 15. Let me see what we're working with. This one seems to be a problem where I have two secants intersecting outside of the circle. So I'm just gonna bold, just like I did before. Circle that a ton of times, circle that once. Circle that a ton of times, circle that once. And let's set up our equation. So here, I'm gonna have 5.5 times 5.5 plus 22.5 equals x times x plus 15. Okay, so let's start this equation by just simplifying what's inside of the parenthesis here. Equals, let's distribute this x squared plus 15x. Multiply these ones on this side. I end up with 154 equals x squared plus 15x. Yet again, x squared term, x term, constant term. Gonna have to factor here. So let's move over this 154. I show my step there. This is left with 0 equals x squared plus 15x minus 154. Okay? So at this point, I'm just gonna factor. I make my t-chart. What multiplies to, and this is a 1, so it multiplies to negative 154. What adds to 15? So just take 154, start dividing it by numbers. In this case, I ended up getting 22 times 7. You're really looking for the two numbers that have the difference over here. So a difference of 15. So those are the two that I got. It has to multiply to a negative, so 1's gonna be negative. Let's see which one works. This one. Okay, so let's go back over here and let's break this one up. I get 0 equals x plus 22, x minus 7. Set each of them equal to 0. I end up with x equals negative 22, x equals a positive 7. The negative 22 doesn't work, however, the positive 7 does, and that's exactly what they want. So I'm going to put that as my answer down here. Wow, we're on the last one already. Okay, so number 16. This is a really cool one. I like this one. It's definitely a nice one to look at. This is gonna be one of the ones where we have a tangent intersecting the secant outside of the circle. I double bold that one. Doesn't have anything to go with. I know there's not going to be anything there. Double bold, circle once. Okay, so let's set up this last equation. Here, it's the one where I'm saying, okay, you're going to put this in parentheses and you're going to put a squared with it. So I get x plus 5 squared equals 12 times 12 plus 15. So in that last one a while ago where I said, okay, so it was the 3x, and I was just distributing in that squared to both, we were able to do that because there was no addition or subtraction inside to break them up. However, this one does have it, so I can't just put a square there. That is how Rational Rabbit dies, so we're not going to do that. So instead, I'm just going to rewrite it plus here, plus here, okay? And then I'm just going to combine the inside just like it's any other problem. I get 27 here. On this side, I end up with 324. Over here, let's FOIL. X squared plus 5x plus 5x plus 25. Okay, let's combine our like terms there. I get x squared plus 10x plus 25 equals 324. Let's move over to 324. I see I have x squared, x, constant. These constants are going to cancel them out. I know we're going to factor. X squared plus 10x equals 0. Let's see what we get there. We're left with a negative 299. Okay, so these ones you might not know in your head. Grab a calculator, see if you can start dividing it by stuff. I'm going to set up my T-chart at the same time. So here we're going to multiply to negative 299. We're going to add to 10. I already checked there's a 1 in front, so we're good. Okay, so let's break down negative 299. In this case, I get 13 times 23. They have a difference of 10. I need them to multiply it in negative, so one of these needs to be negative. Let's see which one will end up working in our case. We want them to add to positive 10, so I'm going to choose the top one because this number, the bigger number, has that positive sign. I'm going to go back to my problem over here and split it up. I get x minus 13, x plus 23 equals 0. Set each equal to 0. When I do that, I get x equals 13. X equals negative 23. Okay, so let's see which one works. In this case, when you plug it in, this one won't. So I'm going to just cross that one out. The 13 will, however, and that is my last problem. I put it in my answer, and we're done.